Welcome back to Aurora Tech Channel. Today, I will be reviewing the Sovol SV07. At first glance, it looks like a SV06 with Klipper firmware, but it's actually a new design, and the hardware is quite different from the SV06. Let's take a closer look at this new SV07. This is a bed slinger with a print volume of 220 by 220 by 250, or a typical Ender 3 size. It uses rubber wheels and T-slots for the motion system instead of the linear rods you saw in the SV06. Honestly, I won't take the claimed maximum printing speed of 500 mm per second seriously on a bed slinger, but I think the recommended speed of 250 mm per second is more realistic. The maximum nozzle temperature is 300 degrees Celsius, and it comes with a brass nozzle. It has belt tensioners on the X and Y axis, and it's using better quality Gates timing belts. The Z axis is using dual lead screws and dual stepper motors controlled by two stepper drivers, which means you can use the auto gantry leveling feature. It uses sensorless homing on both the X and Y axis, and it comes with an inductive sensor for auto bed leveling. There are still 4 leveling knobs and springs underneath the print bed for you to manually level the 4 corners. It also comes with a few spacers for you to replace all those springs and knobs and instead rely solely on the inductive auto bed leveling sensor. It's a bit confusing to have 2 different options, but I will test these out later. The power supply is a Meanwell 350 watt. The motherboard is a regular 32-bit board using an STM32F103 chip and TMC2209 silent stepper drivers. The Klipper firmware is installed on the screen, as the screen is actually a mini Klipper pad from MakerBase, and is basically a Raspberry Pi alternative control board plus a 5-inch touchscreen. The processor is a Cortex A53 quad-core 1.5 GHz with 1 GB memory. It uses standard Klipper screen user interface, and it supports a Wi-Fi printing feature using the Moonraker API for you to send print jobs directly from the slicer, or using the Fluid web interface to upload files and manage the printer and Klipper configuration files. The screen has a total number of 3 USB ports. So, besides one being used by the SV07, it may have the potential of having a camera added or even controlling another printer. Besides the standard size part cooling fan, it also has an auxiliary fan at the back of the machine to provide strong cooling. I would like to thank Sovol for sending me this machine to review. Before we get started, I would also like to thank VOXELPLA, who is sponsoring today's video. VOXELPLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500 mm per second while maintaining a flow rate of up to 25 mm3 per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA Pro is also affordable at just $16.99 for a 1 kilogram roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. They have recently launched new filament colors, as well as the Vision Enclosure Kit that includes all the necessary parts to fully enclose your BambuLab P1P. For more information, please visit voxelpla.com. The packaging of this SV07 is in line with other Sovol machines. It's protected by multiple layers of laser-cut foam. The components included are the base with a double-sided textured PEI sheet, the gantry, the print head, the 5-inch Klipper pad, the Klipper pad mount, filament holder, and an auxiliary fan. Putting this machine together will take around 15 minutes. It won't be any more difficult than other bed slingers. Every time you turn on the machine, don't expect it to turn on right away. The Klipper pad won't show anything for the first 10 seconds. If you think it's not powering on and try again, you may fall into the power on and off loop and think the machine isn't working. Okay, the first thing I will do is bed leveling. Inside the leveling menu, there are several options that may seem a bit confusing, particularly for those who are new to Klipper. First, Z Calibrate. This option is just the Z offset. It allows you to adjust the offset value for the Z axis, which helps you get the right first layer height. Second, bed level. Selecting this option will move the print head to all four corners and let you adjust the level using the spring and knob underneath the bed. Third, Z tilt. This involves the auto gantry alignment. It aligns the gantry using the bed leveling sensor, ensuring that it stays parallel to the bed surface. Lastly, bed mesh. This is auto bed leveling. It will perform a 25-point probe using the inductive bed leveling sensor. Next, I will heat up the nozzle and load some filament. The extrude menu also has a few buttons. If you use the load and unload button, it will move a certain length of filament that you have no control over. It is mainly used to handle the loading and purging or unloading a filament from the extruder, which lets you easily remove it. On the other hand, when using the extrude or retract function, you have the ability to control both the speed and length of filament movement. This gives you more precise control over the amount of filament being extruded or retracted. Okay, let's start our first print. I will start with a 25-minute 3D benchy. The nozzle is set to 195 degrees Celsius and the bed is set to 50 degrees Celsius by default, but I think the temperature may be too low, so I will just change it to 210 degrees Celsius and 60 degrees Celsius, which makes me feel more comfortable printing on a textured PEI sheet at a higher printing speed. As the auxiliary fan is louder than a normal part cooling fan, I will test the sound level as well. It's not quiet, but it's around in the low to mid 60s, which isn't too loud to me. The benchy ended up taking 26 minutes, which is in line with the estimated time, as after changing filament, it still needs a minute or so to heat up again to the printing temperature. The surface is not as clean as a 1 hour 50-minute benchy, but the surface still isn't bad. There isn't much ringing. And the cooling is also good as the auxiliary fan is blowing directly on the print. The machine comes with a USB drive that includes a skin Cura by Sovol. Is its included printer profiles for the Sovol full lineup, including this SV07. If you want to send print jobs directly to the 5-inch Klipper pad, you need to download the Moonraker plugin from the marketplace, then enter the IP address of your printer. You can use any IP scanner or log into your router to find the IP address. Just look for something called MKSPI. Also, check the preview thumbnail using UFP format. We will slice a calibration cube and send the print over the network. The estimated print time is 10 minutes, but the print actually finished in 15 minutes. If you don't include the heating time, the print finished in around 12 to 13 minutes. There is some ghosting on the X. These two are the seam lines, which is normal, as the default print profile is used to set the sharpest corner instead of putting it at the back. The Y surface also has a little bit of ghosting, and the Z surface is a little bit rough, but the overall dimension accuracy is not bad. Then, I will print a larger print, a Spider-Man model by Eastman. The estimated print time is less than 2 hours, but I think the actual print time will be longer, as this print profile doesn't very accurately estimate print time. I will use the same default print profile to print at 250 mm per second. The maximum acceleration is set to 8K, which is pretty aggressive. When I checked the Klipper firmware settings, the acceleration was also set to 8K, so let's see how it performs. The slicer doesn't support the auxiliary fan, so it won't be activated automatically. I have to manually turn it on using the touchscreen. In fact, there are some other ways to control the fan, but I will discuss these later. Let's test the sound level one more time. It's in the same low to mid 60s range, so it's in line with the sound level of printing the 3D benchy. The model finally took 2 hours and 37 minutes to finish. It's definitely not the 1 hour and 55 minutes that the slicer estimated, but it's still very fast compared to an Ender 3, which needs 13 hours to print the same model. The print quality isn't that bad, despite some overhanging that wasn't perfect, and the auto support generated by the slicer is not supporting the chin too well. After removing the support and the overhanging, it still looks pretty good for a 2.5 hour print. Next, I will print this dragon model using auto tree support. The estimated time is just around 4 hours, but I would expect it to take a bit longer as this print profile doesn't seem very accurate in terms of estimating the print time. I also printed this model on many other printers, the average time being around 16 to 18 hours. It took a little less than 6 hours, which is pretty far from the 4-hour estimated time, but it's still much faster than other regular 3D printers. The tree support is easier to remove compared to traditional support, and the surface from the side and the back all look good, and I don't have any complaints about this print. It looks as good as the one I printed last week on the Creality K1. After that, I will print this tank. I will rotate it 60 degrees, so I don't need to add too much support. I will also add a support blocker, so the slicer will only add support to this area. The estimated time is around 1.5 hours, and the support looks good and it shouldn't be too hard to remove. It finally took 2 hours and 4 minutes. It looks alright from the side. The support materials at the bottom are quite easy to remove, the top of the tank looks good, and all the details are printed successfully. As this machine comes with a set of spacers for you to replace the leveling knobs, and I will try to use the spacers and solely rely on the bed leveling sensor and see if it will work. I will try to print a single layer PLA sheet on this new setup. I actually printed a few of them without success, mainly because the Z offset was not set low enough. However, the final one seems to be working. The result is almost perfect. Some areas like these two corners are squeezed too much, but the whole first layer can be peeled off like a plastic sheet and the lines aren't separated. Then, I will print a model of a Suzuki version of the Jeep using fire orange voxel PLA. The print finished in around 3 hours. The top and the side looks good, and the side on the textured sheet was also printed well, but the layer lines at the back are not looking good. This shows the disadvantage of using a bed slinger when printing at a high speed. Compared to the one I printed using the Creality K1, which is a Core XY machine, the layers look much better. Next, let's try some different materials, starting with the TPU ball. As flexible filament may not be able to be printed as fast as PLA, I will reduce the speed to 60 mm per second. This ball is about the same size as a golf ball, and it took 1 hour and 15 minutes to finish without any issues. After that, I will print a tool holder. I slowed the speed down to 150 mm per second for PETG. This tool holder has simple geometry, and the layers printed quite well. Since the maximum nozzle temperature is 300 degrees Celsius, but the printer only comes with a brass nozzle, I won't be printing any nylon carbon or glass fiber. Instead, I will try some polycarbonate to print a pair of needle nose pliers from 3dprinted.hardware.com. If you're interested in their design, I put the link to their site under the video. The printing temperature is set to 275 degrees Celsius, and the bed temperature is set to 110 degrees Celsius. The estimated time is 42 minutes, which is still pretty fast even though I slowed down the print speed to 150 mm per second. It ended up taking 51 minutes. The Polymaker PC filament is quite easy to print, and the tool is rigid and looks alright. However, the flash logo at the center of the bed came off a little and left a mark at the bottom of the print. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The print speed and quality of the SV07 surpassed my expectations for a high-speed bed slinger, especially considering its price point. It's capable of achieving a print speed of 250 mm per second with an 8K acceleration. While the cooling of the SV07 may not be as effective as the K1, and its top speed is slightly slower, the overall print quality is comparable to the K1. However, for some models, the layer quality may not be as good as the K1. The Klipper firmware on the SV07 is more or less unmodified, so it works well. The factory calibrated input shaper values are also precise. I was able to do all test prints using the stock parameters without the need for recalibration. 2. It uses a mini 5-inch Klipper pad from MakerBase. Usually, I'm not a big fan of MakerBase motherboards and their screen UI, but MakerBase is doing a pretty good job this time by not adding a whole bunch of their own stuff or trying to rebuild their own user interface. Instead, they've opted to use the standard Klipper screen as the touchscreen UI and the standard Fluid as the web interface. They've also left the Moonraker API untouched, with only a few simple macros added on the screen. This approach ensures a streamlined and user-friendly experience without any unnecessary modifications. 3. The auxiliary cooling fan on the SV07 effectively keeps up with the fast print speed. I find the noise level ranging from the low to mid-60s in decibels to be acceptable and not too loud. I can tolerate this level of noise, especially compared to other experimental projects that I've worked on. I will talk more about the fan in the cons section. 4. The machine uses sensorless homing, which eliminates the need for physical limit switches. This design not only improves the appearance of the machine and simplifies the wiring process, but by eliminating the need for additional space for limit switches, the SV07 can also maximize the available print volume. 5. The dual Z-axis stepper motors of the SV07 are controlled by two independent stepper drivers. This configuration allows the printer to use the leveling sensor for automatic Z alignment. This method is superior to the Prusa approach used on the SV06, which involves moving the Z-axis all the way up and relying on the gantry to physically align with the top stopper. 6. The quality of the textured PEI sheet included with the SV07 is better than the one on the SV06 and SV06 Plus. It is double-sided with better adhesion for PLA, PETG, and TPU prints without the need for additional glue. However, when printing materials like ABS and polycarbonate, I still want to apply glue to prevent warping. 7. The planetary direct extruder and hot end combination is working pretty well. Both can keep up with the printing speed of around 250 milliliters per second, and I only needed to slow down for PETG and TPU. 8. The acceleration of this machine is set to 8,000 milliliters per second cubed, which is super aggressive for a bed slinger, but I didn't experience any layer shift or huge quality decrease with this high acceleration. 9. The bed leveling is working fine. When I removed all the leveling knobs and just used the spacers that came with the machine to support the bed and make it unadjustable and solely rely on the bed leveling sensor, it was still able to print the single layer print nearly perfectly, so it's more than enough for regular 3D printing. However, this assumes that you have correctly set the Z offset using the paper test. Otherwise, you may still encounter difficulties in getting that ideal first layer. Now for the cons. 1. The biggest complaint I have about this machine is its motion system. Instead of using linear rods like the SV06 and SV06 Plus do, it uses rubber wheels and T-slots. This decision is quite disappointing, especially considering that the machine's main selling point is fast printing. Opting for rubber wheels instead of linear rods on a fast machine seems unusual. Not only do rubber wheels wear out faster when printing at high speeds, but you also need to pay close attention to the eccentric nuts for adjusting the firmness that the rubber wheels grip the T-slots with in the X and Y axes. On a regular Ender 3, if the nuts are slightly too loose or too tight, it might still work. However, on a fast printing machine, if these nuts are not adjusted precisely enough, it's more likely to cause layer shifts, especially on the Y-axis. Considering that linear rods are not that expensive, even when purchasing them at retail price on platforms like AliExpress, if we say 6 rods and some linear bearings are required for this printer, it would only cost around $30 to $40. Since Sovol is a manufacturer and can buy these components in bulk, the cost should be even cheaper. I would be more than willing to pay an extra $30 if this machine were equipped with linear rods. 2. The auxiliary fan is functional and quite powerful. The sound level, ranging from the low to mid-60s in decibels, did not seem that loud to me. However, the main issue is that it cannot be activated automatically. Currently, you have multiple options to control it. You can manually turn it on and off using the touchscreen, so you can manually activate the fan after the first layer or the first few layers have been printed. Alternatively, you can manually add the set fan speed command to the G-code file using a text editor. You can also use the G-code substitution feature in the Prusa Slicer 2.4.1 or newer versions to replace M106 with M106 followed by the set fan speed command using the new line character. Furthermore, you have the choice to modify the Klipper printer.cfg configuration file by adding the multi-pin parameter. This will make the auxiliary fan turn on and off simultaneously with the part cooling fan. No matter which method you use, printing PLA will be just fine. But for example, when I print PETG, I may just need 20% cooling using the print head part fan, and I won't want to activate the auxiliary fan. In this case, you may still need to do this manually. Sovol should include this simple setting in the slicer, but unfortunately, this feature is not available even in their customized version of Cura slicer with the SV07 profile. 3. The print head is super bulky and is the biggest print head I've ever seen on a standard size 3D printer. It takes up almost 30% of the print bed size and obstructs the view of the print, making it challenging to inspect the first layer. When you're having a poorly sticking first layer, you always want to check if the nozzle is too close or too far from the print surface, but it's difficult to see anything beyond the bulky print head cover. This might explain why some users have complained about bed adhesion issues, as it may not be solely due to the bed itself, but may also be affected by the obstructed visibility caused by the oversized print head. 4. The filament holder has 2 bearings, which can provide smoother filament feeding. The idea was good, but the bearing is excessively smooth, to the point that when attempting to feed filament through the filament sensor, the filament roll spins. This can potentially lead to issues such as filament tangling, like if the filament becomes entangled with the roller. The fix is simple, as you just need to open up the roller and remove 1 bearing. This adjustment will make sure that it turns smoothly without excessive smoothness. 5. The double-sided PEI sheet is better than those on the SV06 or SV06 Plus, but the flash logo at the center of the bed came off when printing with higher bed temperatures. It would be better to avoid adding unnecessary things at the center of the print surface. Additionally, there is a 100 by 100 mm square on the bed, initially leading me to believe that the heated bed could selectively heat only the center zone, potentially saving power when printing smaller models. However, it turns out that the square at the center is purely cosmetic, so I'll count this as another unnecessary thing at the center of the bed. It would also be better to add 2 alignment screws at the back of the bed for the print surface. This would stop the corner of the print surface from sitting on the heated bed cable when it is pushed slightly beyond the intended position. 6. The nozzle is the same as the SV06 Plus. The hot end is volcano style, but the head of the nozzle is the MK8 style, which is longer. So, you can't use volcano nozzles on this machine, or the fan deck will make contact with the bed before the nozzle does. 7. The MKS 5-inch clipper pad is functional. It's much better than other MKS products I've tested previously, but it still has some minor issues. For example, when turned on, it takes about 10 seconds before displaying anything on the screen. This can cause confusion for users who may mistakenly assume that the machine is not being powered on. Also, the screen brightness is not sufficient, and I couldn't find an option to adjust it in the screen menu. Additionally, there are no options available to set the time zone and the date from the screen. To adjust this, you need to log into the Linux system using SSH and manually use commands to make the necessary adjustments. Furthermore, the hostname functionality is not working as expected, requiring users to use an IP scanner to locate the Klipper pad. However, if the Klipper pad was set up using the kiosk script, it is possible to use the script to install Avahi and change the hostname and enable accessing it using a hostname, for example sv07.local within the local network, rather than using the IP address. In conclusion, my original expectations were for Sovol to include the 5-inch maker-based mini Klipper pad in the SV06, make some minor upgrades, and launch it as the SV07, their first Klipper printer. However, this was not the case. I understand that using linear rods would increase the cost compared to rubber wheels, but the time and effort invested in redesigning the SV07 also comes at a cost. I would rather see this machine priced at $30 higher and use linear rods. It also appears that the launch of the SV07 may have been rushed, leading to certain details not being well polished. I hope that Sovol takes note of all the suggestions mentioned in my cons section, as they do have the potential to bring about significant improvements in their future machines. However, this machine does remain a solid choice despite some drawbacks. It's one of the most affordable bed slingers available, with stock Klipper firmware that delivers presentable print quality. In fact, it's the best low-price Klipper bed slinger I've tested so far in terms of print speed and print quality. For $340, it offers better performance and print quality compared to spending $150 to buy a Sonic pad or whatever Klipper pad to upgrade your Ender 3 or other Marlin bedslinger printer, as upgrading your existing printer will not provide you with the same strong auxiliary cooling fan, robust extruder, higher flow hot end, and the well-calibrated input shaper parameters on the SV07. For potential buyers, if you are already familiar with Klipper, especially those who have attempted to Klipperize their 3D printers, using this machine should not present any big challenges. In fact, you will probably appreciate the speed and print quality it offers in comparison to your own DIY Klipper conversion projects. If you're only used to Marlin firmware, there may be a learning curve when transitioning to Klipper. In terms of beginner friendliness, I would not categorize this machine as being super beginner friendly. However, I believe that starting with the Klipper firmware machine instead of Marlin is a better option. There's no need to spend time on a slower 3D printer before experiencing the joy of significantly faster printing speeds. If you are interested in the Sovol SV07, I put the link under the description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time. You can also use the G-code. The Klipper firmware on the SV07 is more... Go away! The design of the print head and the cover are just not the best. Like,